Okay, good morning once more. Super excited to welcome you back to this session where we're going to look at the very last topic of HCIP, R&S, and the third module, IEEP. So the topic is titled Network Migration. So how do we carry out a network migration project? So with the development of enterprise services, enterprise networks are reconstructed and optimized continuously to meet the service requirements. To meet the service requirements. So that network that we used in 2010 that was supporting about 2,000 students cannot be the same one that is supporting over 6,000 students today. That network that could not support integration with bank APIs in order to in order for the fees that are paid by the students to reflect almost immediately on our servers, finance servers. The same network cannot really be able to achieve such service requirements. So operations that affect running services on the live network are defined as migration projects. So any operation that can affect the running services on the live network is a migration project. For example, operations leading to service interruption, hardware capacity expansion, software upgrade, changing the configurations of your device are considered as network migration projects. Now, before performing any of these operations, enterprises prepare strict operation flows and risk mitigation measures based on the service security level requirements. So this course allows trainees to get familiar with the migration flow and operation specifications. Also, you're going to master risk control measures and thereby efficiently and smoothly be able to complete the network migration process. Very interesting topic here. So by the end of this chapter, you should be able to, John?
Upon completion of this section, you will be able to, 1, understand the definition of network migration, 2, master the standard migration operation procedure,
Yes.
and 3, be familiar with common migration scenarios.
Exactly. Thank you very much. So let's begin by looking at the overview of migration. So due to new service requirements, the enterprise network will always change in order to support these particular service requirements and the ever-changing business environment. Now, this is a small story here of a network. For example, the MMU network in 2010, which was meant to support a few students and therefore had little service traffic volume, and therefore the implementation of this network architecture, as you can see, was just a simple structure or topology. Now, as the university, for example, grew, we needed to increase, for example, the service traffic volume, that is the bandwidth, and also be able to provide at least more than one paths, alternative paths. Thereby, we actually expanded the aggregation layer so that we can be able to have multiple paths to the egress router, and so that we can also be able to expand our network and be able, for example, to create new labs. Now, after a while, we also needed to provide backup links to our ISP, and therefore we did an egress reconstruction. So at the core layer, we added another router and thereby had multiple connections to our ISP. So how can we ensure smooth service transition when networks are upgraded, expanded, and reconstructed continuously? So our main objective is, when we are doing such like a thing, how do we ensure smooth service transition? So this is a good example of how the network can expand over time. So we begin by expanding the aggregation layer, which generally means that also the access layer is going to expand. And then when need arises due to bandwidth requirements or something, then we might also need to expand our egress at the core layer for redundancy and also for bandwidth, because you can configure them to work, for example, in load balancing mode. Okay. Now, network maintenance methods. Network maintenance methods. Now, as we said, every device has a product life cycle. So in order to improve the security of the devices, the efficiency of the devices, after some years, in most devices between 5 to 10 years, we need to replace the device with a new high performance device. So one of the ways in which we can do network maintenance is by replacing a device with a high performance device. So for example, we have an egress router that has been working for the past 5 years. So we simply need to replace it with a more current router, which will support more efficient features and will most likely outperform the old router in terms of processing capacity, memory, and the technologies that it can be able to support. So when a core egress device is replaced, a large number of services may be interrupted. So that's the challenge. That's the challenge. Now, other than replacing the devices, sometimes you also need to change the links. We know that we have different technologies to connect to the internet. One of them is MSTP, a multi-service multi-service transit something. I can't remember the rest. But MSTP is a SDH, uses SDH to connect. And actually, this is the traditional list lines. When you want to connect the headquarters, for example, with the branch, we know the problem with list lines is that they are very expensive, even though they are more secure and their bandwidth is more certain. So normally nowadays, what has become mainstream is connecting over the public network using VPNs, for example, MPLS VPN. So again, if you're changing this link between yourself and your ISP, you see it means that you're changing technologies. You're changing technologies. You have to do a lot of configurations in order to be able to change from this technology to this technology. So link changes also involve service configuration adjustment as well as physical line switchover. So it's not just about the configuration, but sometimes also the physical line. You're also changing the line. So these are some of the network maintenance methods. Now let's have an overview of migration. Now, if technical migration operations may affect the running services on a live network, we need to perform the operations in strict compliance with the preset operation procedure and take risk control measures. Now, generally, this type of project is defined as a migration project. As we said, any operation on your network that may affect the running services on your live network is referred to as a migration operation. Now, as we've said, a migration operation is a high risk business, and therefore you should do a lot of planning and know how to do it. Now, a few ways in which we can do migrations. Migrations entail some of this. Expansion, we've already seen, when you want to expand your network. When you want to reconstruct your network, for example, you want to change the topology or expand the topology. When you want to replace devices, for example, if they have reached their end of life, or you want to modify traffic or service paths through configuration. All these might affect the service, and therefore all these operations are risky and are considered network migration projects. So you need to conduct migration according to the procedure and the standards in order for you to reduce the risks and be able to mitigate the risks in case you run into problems. Now, migration is a difficult procedure, and some of the things you're supposed to consider when you're doing so is to estimate the risks. Then you come up with a scheme. So this is the procedure of how you're going to implement the migration project. Then you make sure that you strictly comply with this particular procedure. So these steps are not very easy. To estimate the risks, to come up with a perfect migration scheme, and to also perform the migration smoothly by strictly complying with the scheme. They're not easy. They're not easy to do. So you're going to have a lot of questions, but if you plan this well, then you're going to achieve this well. So you ask questions such as, where do the risks exist? Then how can I make the perfect scheme? And also, what implementation methods should be used during the migration? So we're going to look at we're going to answer some of these questions in the coming slides. Oh, went back. So let's look at the operation procedure. So migration operation procedure, normally this is done in 3 phases. So preparation phase, then implementation, then closure. Very important. So in the preparation phase, we do the project survey to find out, for example, things like the scope of the project's requirement analysis, what they need, for example, to be changed, risk assessment. Then we prepare the project migration procedure, that is what we're calling scheme, and we seek approval for the procedure that we've come up with. So we're going to see how that is done. Then implementation phase, we look at the migration preparation, then we do the migration, then we test the service and monitor the service for some time. Then if everything is okay, we close this particular project by doing site attendance and ensuring that the customer gives us, for example, a project acceptance certificate. So they need to sign that particular documentation. So those are the 3 operation procedure: preparation phase, implementation, and closure. So now we're just looking at some of the things that we've looked at here. So for example, the preparation phase, we need to do requirement analysis. So for example, we can do a network status analysis. So from here going forward, we are going to be looking at a scenario which will relate to this story that you're having here. So you need to understand it at this point. So the network of company A has been running for many years. Now, with the development of services, the traffic carried by the core egress router is increasing, and the router's in-service period is close to the device service life specified by Company A. Therefore, Company A requests to replace the old router at the core layer with 2 high-performance routers. So this is what they want to replace the old router at the core layer with 2 high-performance routers. You see, this was the topology or architecture, network architecture. This is what they're using. This is what they want. So they're simply changing expanding their egress by adding another router and replacing, eliminating the old router so that they have 2 new routers. So that is the scenario. So let's look at how this can be handled. Now, the first thing we need to carry out, now this is the engineering team is to do a project survey. So Company B is responsible for that project. So when they receive the network reconstruction request from Company A, Company B will assign a network expert, we're calling him Tom, to visit the site and conduct analysis and survey. Now, what will this guy do? Tom will communicate with Company's A network owner, frontline maintenance engineers, technical contact person of the ISP. So we're looking at the in-house engineer for Company A. We're looking at a technical person from the ISP. And lastly, a vendor rep. So they have to talk to these three. After they talk to them, they're going to collect network information. So network information including the topology, so the network architecture, the version, the configuration, the service traffic path, etc. So that is what is done during the project survey, trying to find out about these details and to also be able to form the team that is going to work together in coming up with this information and validating this particular information. Now, after the survey, we are supposed to do a project analysis. So after 1 week of research, so research is the project survey, Tom will analyze the customer requirements based on his rich network experience. So these are some of the things they look at. I think we looked at this in earlier slides. So necessity, a migration necessity. So they need to make it clear. So for example, the core router, the core egress router has been running for a long time and is carrying more and more services. So is it necessary? Yes. Therefore, it needs to be replaced and the network needs to be reconstructed. Then feasibility. How possible is this? So after communication with the vendor rep about technical details, migration is considered to be feasible based on personal experience and historical devices. So you see, this guy is the one that advises. Do we have the technology? Do we have the technology to support these new requirements? Then risk analysis. So this will involve the replacement of the egress router. So this will definitely lead to service interruption. So it's a risky operation. Then qualitative analysis. So things like the network architecture, traffic, and so on needs to be carefully looked at, and also the technical positioning. So the core egress risk construction may cause great risk to services running on the entire network. Therefore, it is defined. So technical positioning, it is defined as a migration project. Okay. Now, Tom is going to propose two migration schemes for subsequent discussions with the customer. So they need two new routers, but how do we implement this migration? So normally the technical engineer is supposed to at least offer options and also explain to the in-house engineers the advantages, the disadvantages, and the risks that are involved in following each of the scheme. Now, one of the scheme we can use in this particular example is either a direct replacement. We can do a direct replacement, or we can do a gradual replacement. So let's look at the direct replacement. So here, we want to change this old router. So how we do it is we remove it, then we replace it with a new one. Okay, let's look at gradual replacement. Gradual replacement is this. We want to replace this old router. Before we replace it, we can add the new router. You see, we're adding the new router here, and the old router is still there. Then, if this works correctly, we remove the old router. Yes, we remove the old router so that we achieve the same architecture again as we had in the beginning. So this is direct replacement and this is gradual replacement. From how you look at it, what do you think are some of the advantages of direct replacement over gradual replacement? Anyone? What do you think are the advantages of direct replacement and gradual replacement? For example, let me ask, which one do you think will take longer to implement? Is it direct replacement or gradual replacement? Which migration is going to take more time?
Gradual replacement.
Exactly. Gradual replacement is going to take more time. Therefore, in terms of implementation time, direct replacement is faster. Now, in terms of risk, which one do you think is more risky? Which one do you think can be able to interrupt services? Which one do you think is more risky than the other? Direct or gradual?
Direct.
Exactly, because we don't have a backup. We don't have a backup, and therefore, even if we try to roll back, we might not be able to get back to where we want as fast as we may do in this particular architecture when we're using gradual replacement. So those are some of the advantages and disadvantages of each one of them. Of course, the other advantage of direct replacement is that it consumes less resources. It consumes less resources, of course, in terms of not just time, but also the device and so on and so forth. Because you see here, for example, we're going to need new lines. We're going to need new lines and therefore do configurations here and here, etc., etc. Now, generally, we do direct replacements in small-sized networks. And these small-sized networks normally are ones that have no key services. No key services are going to be affected when you do the direct replacement. So normally we don't implement this in a very huge network. On the other hand, gradual replacement is for large size networks with key services. Okay. So again, gradual replacement, easy to roll back. Direct replacement, not very easy to roll back because of what you can already see there. So normally we have to do detailed risk analysis and assessment on the migration. Some of the important things we look at here, for example, are the affected scope. So which parts are going to be affected? In that example that we just looked at, where we are going to replace the egress old router with 2 new routers. You see, we are actually affecting the entire network. Then the other thing you need to look at closely is the affected duration, because the affected duration then is actually, the affected duration means service interruption. Affects is directly related to the service interruption time. So services are going to be interrupted for about 5 minutes to 120 minutes as we do the migration. Also, we look at the loss that may be caused by the risks. So for example, failing to recover the company's services, and also some of the risk mitigation methods. For example, instead of replacing everything at the same time, we can implement segment by segment migration. As we are going to see, we also need to plan for a rollback, and also be able to have what we call on-site spare part replacement. So we can have a backup device that we can be able to use as a replacement in case of failure. Okay. So after doing the risk analysis and assessment, we need to communicate. We need to communicate with the vendor through a meeting. So the parties involved, we have the vendor, we have the ISP, then of course we have company A and the engineering team. And normally we also have the supervisor. So some of the things that the vendor can help us do, for example, is the model selection. So this is the work of the vendor. So we will provide high performance routers of new models that apply to the various scenarios. Corresponding quality reports and cases are available. Then for the egress interconnection, we need to involve the ISP or the carrier, because we might need to change that. Then for the risk assessment, we need to highly involve the customer, party A. Are we willing to invest a large amount of time and funds to ensure that services are running properly? So those are some of the questions that will be looked at. Then for the scheme selection, so how do we do the migration? Do we do segment by segment? Or do we do gradual or direct? So for that one, the contractor. Here, the contractor is choosing to go the gradual replacement way because it's going to minimize the risks. The supervisor will cooperate with each other and work together to complete the reconstruction project. So the work of the supervisor is to coordinate this entire team so that communication can be able to flow and ensure that everyone plays their role in a timely and efficient manner. So let's see what we do during scheme preparation. Scheme preparation, as we said, is simply the procedure for implementing the migration. So we can also call it the migration scheme. So again, we've said that the first thing you need to do is a project survey. We've already looked at the contents of the project survey. Then you do project execution. And lastly, you do project acceptance. So in project execution, you look at, for example, the migration preparation, the implementation, rollback solution, and any emergency response plan that is needed. At the acceptance, we need to test the service, ensure they are working normally. Service test. We need to visit the site, ensure that, for example, the new routers are there, then hand over any documentations that we used, and finally sign a project acceptance certificate. So scheme verification and review is an important meeting. Normally, it begins with a first office application, technical review of all the parties, deployment for testing. So scheme verification and review is we're holding a meeting so that we tell them the plan, what we've just looked at in the previous slide. Then, other than meeting company A and company B, they meet and discuss about the scheme. They also need to consult the vendor so that they get the expert view on their scheme. And lastly, they need to sign and agree that that is the scheme that they are going to use to carry out this particular migration project. So on migration preparation, there are a few things that we need to do. So migration preparation is a key procedure before doing any migration, and is actually considered as the basis for successful migration. So normally, we need, for example, to do environmental preparation. In environmental preparation, we check things like the hardware, if they're working normally, the software. Then we also look at the tools that we need for that particular day and whether we need any spare parts, which are quite important for rollback. So, for example, for a hardware, we can check whether the device is able to power on normally. So we do a power on test. Remember, this is the new device that we've just bought, the routers. Are the cards also operating well? Are we able to do a connectivity test, for example, using a ping and so on and so forth? For the software, we check things like the version, the license, the scripts, etc. So for example, the license, we know that when you're having a new device, sometimes you have to apply a new license. So you need to check and be able to ensure that they are working normally. The new license is working normally. Okay, or has been installed actually in the device. Then tools, you might need transportation tools in order to get to the site, mounting tools, migration tools, etc. Testing tools, for example, network cable tester, optical power meter, etc. Commissioning tools like a laptop and any software that is needed. Monitoring tools like the monitoring, traffic monitoring tools like Wireshark, etc. And any spare parts that you might need. For example, cards, backup for old and new software versions, backup for old and new scripts. When you talk of scripts, you're talking of the configurations. Other than the environmental preparation, sometimes we also need to do personnel preparation. So in personnel preparation, we look at the participants list, the participants' responsibilities. So everyone with their responsibilities and their contacts. The other thing we might need to look at is the procedure preparation. So in procedure preparation, we're looking at the time schedule and comparison tables. So the overall migration time, the service interruption time, and the rollback time should be clear from the onset. So these are things we are doing before we perform the migration. So comparison tables, for example, you might need a comparison table for the physical and logical topology of the old and the new. Service configurations before and after the migration. Comparison for the software version before and after the migration. Analysis and comparison of the control planes, analysis and comparison of the data planes, so data flow before and after the migration. So you need comparison tables that show clearly the difference between the before and the after. They are important because they also help you during rollback in case you have an issue. As a thumb of rule, for example, when it comes to the time schedule, you see we have the overall migration time. One of the rules is that we do not perform migration in peak hours. We only perform network migration when people are not intending to use the network services. For example, during holidays or during the off-duty time, depending on the company's operation time. So keep that in mind. So after doing the preparation, we need to do implementation approval. So it must be signed by the customer. So the overall migration scheme must be approved. Approval means it has been signed by the customer. And then a change application form must be submitted before each specific operation. So that particular change application form must also contain the signature of the specific owner authorized by the customer. So before each migration change, all involved personnel must be notified through email, telephone, or SMS. These documentations are very critical. Very critical. So always make sure you have them. Okay. Sometimes on a large migration project, we break the large migration project into smaller, more manageable migration steps. So we decentralize. Instead of seeing it as a one big project, we decentralize it. That leads to simplification because now we can be able to look into this, perform it within a very short time. So we simplify it and we perform the migration one by one, step by step. So this is very important for a large migration project. Okay, so let's look at the migration roadmap. Just as a reminder, what we were looking at, the scenario where Tom and company B need to replace the egress router. They need to replace the egress router, the old egress router. It was one. They now need to implement 2 new routers at the egress and remove that old router. So this is the migration roadmap. So number one, so they have divided it into several phases. So phase 1, phase 2, and phase 3. So at phase 1, we want to do device deployment. So what is device deployment? We connect the 2 new routers. We connect the 2 new routers with the aggregation layer devices, and we also interconnect them like that. Now, after that, we observe the device running stability for at least 2 weeks. So after connecting this at phase 1 and doing the required configuration, then we check how the network is operating. We observe for at least 2 weeks. So remember right now, traffic here is still being routed through the old router. But we've just done this connection and we are testing it to ensure that they're running well. But we've not interconnected these routers to the ISP. We're seeing that. Now in phase 2, we now connect the physical line between the new core router to the ISP network here. So we connect this router let's call this router 1 to the ISP. Now, after doing that, we perform a switchover. So by performing a switchover, we are moving traffic now from this line to that new line. So here we can use default routes. We can use default routes to advertise now the new default route to the aggregation routers or switches. Now, after doing this switchover, we need to observe the service running stability for about 2 hours to 24 hours. So is traffic now following this path? Is traffic now following this path? Okay, now in phase 3, we now do the following. Old device removal, that is the summary. But the first thing we do is that we disconnect this link. We disconnect it from the ISP. After disconnecting it, we connect the second router to the ISP. Then we disconnect this connection between the old router and the aggregation layer router or switch, and we also disconnect that link. Thereby, we remove the old device. We remove the old device that way. So that is how we do that. Now, generally, after connecting this link, we can either configure load balancing if we want, this one here. If we want, we can configure load balancing. And now that way, as you can see, we've done a step-by-step migration, gradual implementation. And as we discussed, we have advantages and also disadvantages for that. Okay, so implementation, migration procedure. So before migration, we need to take a snapshot of the following. For example, the operation objects, including the interface, line, protocol, and traffic information, must be recorded. Also, configuration files must be backed up. So you need to take all these details and back up the configuration files. Then during the migration, we need to deliver the configuration commands or perform physical operations. Also, the execution time of each step must be specified, as we said earlier. Then after that, we need to monitor. We need to monitor the service running by using commands such as display, ping, transat, in order to test and ensure that everything is working normally. So snapshot, then migration, then testing. So let's look at this example. So we said here, after connecting the devices, we check. Then number 2, at phase 2 here, we want to do the switch over of the key point. So let's see how this can be done. So here, let's look in this example. We are taking a snapshot of network environment information. A snapshot of network environment information must be collected. So here, the commands on RTC are used as an example. So commands on other routers are similar. Now, generally, what you're doing is on RTC, we are using the display IP routing table in order to check the routing information. So we want to check what routes are on RTC, because those routes that are in RTC are the same routes that we need to ensure are in RTA and RTB. We need to check, for example, the time range, to check the configuration time range information, display log. So these are some of the things we need to take a snapshot of. So we need to save this information. Display device, to check the device component status. Display version, to check the version of the device. Display OSPF peer, to check the neighbor, the OSPF neighbors. So for example, when you do that, we're going to see that RTD and RTE are neighbors of RTC. And we need to ensure that RT and RTB also form neighbor relationships with at least RTD and RTE. We also can do display ACL in order to check the access control list that we have configured. So after doing that, we can now do the migration. So sorry, I didn't show you this. This was the first thing we were doing, a snapshot. So we do a snapshot by doing these commands, and then we take a screenshot, for example, or copy and paste. It's important that we also record the date and time, or when we did this particular, when we took these particular snapshots. So after doing that, we can now do the migration. We can now do the migration. So we want to do the migration of the service traffic from this link to the new link that is interconnecting RTA to the ISP. So how do we do that? We can go to RTA and configure a static route. So we are configuring a static route, a default static route. So if you get any packets, pass it out through this interface. So after doing that, we need to use this command, default route advertise, cost 5. Remember here, we've gone into OSPF1. So what we're saying is advertise this default static route, but make it have a higher cost of 5, because the other one has a cost of 1. By default, the OSPF cost for static routes is 1. So we are simply saying we want for this one to be 5. The reason as to why we are doing that is so that traffic can continue flowing through here, because this one will have a cost of 1. So yes, we have configured this path, but it's not going to be used. It's not going to be used. So after doing the migration, we need to verify that indeed it's working by using the command display IP routing table. So this should be able to, remember we are doing this in RTD. So we want to see whether this static route that we've advertised, we've configured and advertised in OSPF, has it gotten to RTD? So by using the command display IP routing table, we're going to see whether it's there. Then we can also, for example, specify that particular static route by doing display OSPF LSDB ASE 0.0.0 in order to check the default routes in the OSPF database specifically, not any other, but that default route that is in the OSPF database. So that's how we do verification. Okay, so set the cost to 5 when advertising the default route, so that RTC is still the egress of network services. So I think I've already said that. Then RTA is not the egress of network services, but it has penetrated into the OSPF database. So that is what we want to check when we do this verification here on RTD. So I hope that is clear. Okay. Then what do we have here? Okay, so here we now want to do the migration. We want to do the migration. Note that every time we're doing anything, we record the time. So here we are going to RTC, this guy. So we are changing traffic so that now it shifts to this line. So how to do that? We can go to RTC, OSPF1, then we undo default route advertise. So RTC is no longer going to advertise a default static route to RTD and RTE. So we can verify. For example, in RTD, we can do verification by using the command display IP routing table. So when we do that, we do not expect to find a default route from RTC. We can also do a transat to an IP address of our ISP. So transat that to verify that indeed the traffic now is passing through RTA and not through RTC. So that is how you do verification. If need be, you can do a quick rollback. How do you do a rollback here? By simply going to RTC, for example. If RTA does not work correctly, you can simply go to RTA, go into SPF1 and type this command, default route advertise. You see, rollback then at this particular point becomes very easy to do. Okay, so here we look at the definition of what a rollback is. So is to restore the status before the change. Restore the status before the change. So when do we do that? For example, when the migration or one step fails, rollback must be performed. Rollback must be performed. So as I had said on step 6 there, in case, for example, RTA does not work as expected, we can simply go into OSPF1 and type the command default route advertise. So if RTC advertises the default route, it has a better cost of 1. So the egress is going to be through RTC, which is the old router. So that's how we can roll back. Now the requirement here, for each small migration procedure, the last item must be the rollback instruction. Remember, we were dividing the big rollback, the big migration project into smaller migration procedures. So at the end of each migration procedure, we must clearly indicate the rollback instruction. How do we go back if this procedure fails? So that is very important. Okay, what do we have here? Rollback, we're almost done, by the way. Rollback time. So normally you need to consider such information such as the overall rollback time and when you need to do. When is it certain that I really now need to do a rollback? So in this example, the migration procedure is divided into 3 phases. So rollback requirements and execution time should be specified for each phase. So normally you make a preliminary conclusion based on the on-site environment. So kama kimeshindikana, you perform the rollback in time. Don't waste a lot of time, just perform it. Then, as we've said, the rollback instruction must be included in the migration scheme. At the end of which migration procedure, you should have the rollback instruction. Very important. So rollback failure, let's look at this. Normally, when the migration fails, the network can be rolled back to the original status. So if the migration failure is caused by force majeure, by uncontrolled, unforeseen situations, such as earthquake, flooding, etc., and rollback cannot be performed, the emergency response plan can be executed. So that's why you need an emergency response plan. Force majeure, fire, you have fire, you have things that are beyond your control. So you need to do that. So an emergency response plan must be included. This is another thing. Emergency must be included in the migration scheme. So the emergency response plan should contain the following workarounds. For example, how to reload the system software, on-site spare replacement. So that's why you need spare parts and emergent device invoking. So those are some of the things that you need there. So after doing all this, you need to perform a test. Test. Now this test will only be passed when the customer's application service requirements are met. So some of the things you need to test on is the network running status. We know that you can use the pings and the displays to test the running status of the device, for example, to display the neighbor relationship and so on and so forth. So you need to execute this in each small migration phase, just like we've done when we were switching the line from RTC to RTA, the egress line. We checked whether the default OSPF was being received by RTD. We also checked, for example, whether RTC is no longer advertising the default route and so on and so forth. So these normally you perform at each small migration phase. You also need to perform the network service status test. So you test service connectivity and also the service performance. Normally, this is done executing in the entire migration procedure. So you normally do this throughout. And lastly, you need to do a customer application service test. So test customers' upper layer application services. For example, has the download speed increased, and so on and so forth. And you need to also observe the stability. So normally this is executed after all the services have been restored. After all the services have been restored. Site attendance. Now, nothing much to say here. After the migration is complete and the test customers application services is passed, the network enters a special observation period. So it needs to be observed, monitored. During this period, engineers usually reside on the customer site and observe the network running status to prevent faults. Now, you're supposed to negotiate with the customer to determine the site attendance period. In some cases, depending on the size and the complexity of the network, you might need to spend just 44 hours of observation. Otherwise, if it's a little bit big and complex, 1 week. And for the very large and complex networks, you might need 1 or even more months. So this is the engineering team, company B. You need someone, experienced engineer, to stay on site and be able to respond to any issues that might arise. Then migration acceptance. After the observation, we now need to do the acceptance. So normally we do training. We said one of the major purpose of migration is also knowledge transfer. So we have to do training in order to make the in-house engineers comfortable with the changes that we've made. We also need to hand over any documentations that we've used during the project and come up and perform an acceptance summary meeting. So lastly, we can look at some common migration scenarios. So one of the migration scenario might be device upgrade. So in this migration scenario, you're advised to contact the vendor for technical support. So you have to talk to the vendor. Device might be an entire device. It might be a software version upgrade, or it might be a part of the device. For example, an LPU card. Any card replacement is considered as a migration scenario and is considered also as a device upgrade. So it might be a whole device or the software that is running on the device, for example, VRP, or just a card on the device. The other scenario is a physical structure. Physical structure construction. So for example, adding a link is a physical structure. So you had that particular topology, but now in order to provide redundancy, you're connecting those routers at the aggregation layer. You can also add a device. You can also add a device. So for example, just what we did in that example for company A, we added one more device at the core layer. So adding a device. You can also adjust the structure. So for example, this is how your routers are interconnected. You can implement a new architecture. So that is also an example of a physical structure reconstruction. Very interesting. Then you can also do a network system adjustment. So normally when we talk of this, we are talking of projects that include changing the IP addressing scheme. So for example, you are using 192.172 and 10 dot, and now you just want to use the 10. So when you change your IP addressing scheme, the logical topology, then that is also considered as a network migration project. You might also change the OSPF areas or change the entire protocol, routing protocol. So instead of using OSPF, you now want to use BGP. So you see, that is also considered as a network system adjustment scenario, migration scenario. The other scenario is on network performance. Very interesting again, network performance optimization. So for example, you had not performed QoS optimization. So every traffic is considered with equal priority. So if you perform QoS, then you can be able to differentiate the services to ensure that key services have the highest priority. For example, real-time voice and video services. So when you do that, that is considered as a network performance optimization migration scenario. The other one that you can use is service optimization. Service optimization. So service optimization, for example, is you have two egress routers. Remember, a firewall can also be used as an egress router to connect to your ISP. But you've configured one as the active, and the other one is acting in standby mode. But now, in order to optimize the traffic and usage of your bandwidth, you want to perform load balancing between the two egress routers. So that is what we call service optimization. And that is also an example of network performance optimization. Oh, wonderful. We're now coming to an end by looking at the migration summary. So just a few things to remember: always customer-centric. The principle is to control the risk, and we need to get authoritative certification from the customer most of the time. Then we need to come with a scheme that we're going to follow strictly, and then we execute based on what we have agreed. So generally, this is how we perform a migration. network migration project. Ladies and gentlemen, we come to the very end of this chapter, which also marks the end of the HCIP R&S training and also the end of the IEEP module. Glory to God. Thank you for staying with me all this time and for your support, especially in reading out the objectives, asking questions, and also answering the end of chapter questions. Asanteni sana, and God bless you all.